This one's one I'm really, really excited to see personally. So crazy statistic I read. The information and technology space contributes 2.8% of global emissions, roughly the same amount as the aviation industry. And by 2030, it has the ability to eliminate 20% of global emissions. And so developers have long thought about things of performance, availability, and cost when looking at their infrastructure, but it's about time we add sustainability to this here. So here to walk us through how we can build sustainable architectures with MongoDB, solutions architect, Snehal Bhatia. Snehal.
Hi, everyone. Thanks for joining today for this session, and I hope you're all enjoying the conference so far. I, for one, was very excited to see everyone in person, so I took a flight from Ireland to get here. And one of the most interesting things I've been noticing with these airline companies and websites these days is the little green leaf icon that shows up next to certain flights, just to indicate the carbon emissions associated with it. So who all here are kind of conscious about the impact of the aviation industry on the environment? And rightly so, right? As Dan mentioned, that contributes to from anywhere from 2 to 3% of the global emissions. Now, one thing we all have in common here is like we have developers, SREs, product managers, analysts. All of us spend the majority of our time working with the information and communications technology industry, right? And how many of us here have actually considered the impact that the technology industry has on the environment? Now, if you look around, the number of hands that went up this time was so much smaller. And that is so surprising, given that the ICT industry also contributes anywhere from 2 to 4%, depending on the study you choose to believe, of the global greenhouse gas emissions in the world. And what's even more alarming is that this percentage is estimated to go up to 23% by 2030. Now, we all know that greenhouse gases in excess are not good for the environment. They are one of the major contributors to the global rise in temperature, major contributor to global warming. But how do we quantify this impact? The way I like to think about it is that our planet has an SLO, or a service level objective, of 1.5 degrees Celsius, which I think translates to 34.7 degrees Fahrenheit, but don't take my word on it. So what that means is that if we compare that to the pre-industrial levels, or like before 20th century, the average global temperature should stay within a range of 1.5 degrees Celsius as compared to what we had back then. And if it exceeds this, that is essentially going to be the tipping point where we'll start to see some more natural calamities or disasters or rising of sea levels or loss of biodiversity. Essentially, that's where we'll start kind of losing the equilibrium that we have on the planet. So how are we doing today? In short, not very good. In fact, 19 of the hottest years ever recorded so far have been in the last 22 years. So if we keep going at this rate, we have less than 8 years before we reach this tipping point. Now, that is a problem, but we're all a room of problem solvers. We like a challenge. So what is the challenge here? The challenge is that by 2030, you and I, all of us in the ICT industry, we need to reduce the global greenhouse gas emissions by 45% to stay in range of the 1.5 degree SLO. And I would argue that data and the data platforms we use are core to addressing this challenge. And we'll see throughout the talk today how. So Thanks for joining me today, everybody. I'm Snehal. I'm a solutions architect here at MongoDB. For as long as I remember, I've been intrigued with everything related to data, and a more lofty statement, but really true for me. I also care a lot about ethics and responsibility in technology, using it to make the world a better place. And I have talked about this before in multiple other places, so if you're interested, you can go check some of these out. They're available online on YouTube. And as for what we're going to be seeing for the next 25 minutes or so today, we already talked about the SLO we have and the impact of technology on the environment. So going forth in the next few sections, we'll cover what it means to build a more environmentally sustainable data architecture, especially how the MongoDB data platform can contribute to this. Now, it's important to note here that today we'll just be talking about the environmental sustainability, because sustainability as a term might refer to multiple other things, so we'll be focusing on the environmental component of that. There's also a lot that goes into an application. There's much more beyond the data platform itself, so we'll just touch upon some of the ideas that might help you in the layers other than the data layer, and then we'll have some time for Q&A. So given we have a really packed agenda, let's get into the most impactful way you can reduce the carbon emissions and make your data platform greener, which is hosting on greener infrastructure. Now, infrastructure here refers to servers, data centers, anything you think where you host your data. Now, how many of you here work with private data centers or on-premises deployments? Well, a couple hands up there. I'm sure all of you have also already had conversations about moving to the public cloud at some point, like AWS, Google Cloud, or Azure. And maybe some of the reasons you've not made that move yet might they include like security and privacy or having more control over your data centers, things. So that might have stopped you from making that move. But maybe one factor you didn't consider there is the fact that an average on-premise public cloud migration can result in 84% reduction in carbon. Now, this is driven by efficiencies in cooling and the way the hardware is optimized, and even the cement that is used to build these data centers. And there's some really, really interesting facts and figures on the screen that I'm not going to read out loud, but essentially, the cloud providers are, these three cloud providers that you see on the screen, they are the purchasers of renewable energy around the world. They have really aggressive metrics of achieving net carbon zero or zero waste or being water positive by 2030. And all of this is possible for them, but might not be possible for every organization that is managing their own data centers. And the reason for that is very simple. It is that these organizations, such as the ones you all work with, you're not in the business of managing your IT estate or your data centers. So even if you have the expertise to do it, it will probably never make the top of your priority list. So moving to the public cloud is the first major step you can take to reduce your carbon emissions. And building upon this, the same argument holds true to using a managed data platform. So you're looking at an iceberg on the screen. What it represents is kind of the different components associated with building an application. So when you start out, all you think about is what you see on the tip of the iceberg, the development of the actual features of the application and the optimization of it. But then when you actually start thinking about going into production, there's a whole lot of plumbing that goes into developing an application. So whether that be backing up and restoring your data, whether it be upgrading your database, or whether it be security and compliance of your data, or even like optimizing your storage engine. All of these are extra things that you need to build in to make your application or software a success. Now think about the billions of applications that are being developed around the world today. And think about what happens if all of them start building all of this plumbing from scratch. That is a lot of resources, billion-folds of resources, and not just in terms of number of developers needed or personnel, but also the resources consumed in terms of compute or hardware. So this is where the concept of sustainability of scale comes in. Such a sustainability can be offered to you by a fully managed data platform. such as MongoDB Atlas, which is the fully managed data platform offered by MongoDB. So MongoDB does all of this that you see under the water for you, and we have optimized this and done it in a way that it's most efficient for consuming the resources that go into it. And that is then leveraged by millions of applications and workloads across the world. So you no longer have to worry, not only do you no longer have to worry about everything that's under the water, but also the sustainability of that and the optimization of that then becomes the value of your database platform provider, and you only have to worry about sustainability in the platform. So using a managed service that is deployed at scale across millions and replicated and reused across millions and millions of workloads and applications is one of the ways of achieving sustainability in your architecture. Now, I mentioned MongoDB Atlas. It runs in over 80 regions. What I didn't know, it was 93 regions. I found out in the keynote with y'all today, and it's across the 3 major cloud providers. So we already are running on the public cloud, which is the more sustainable way to go. But did you know that among these regions, there are many, many regions that are powered by renewable energy, or are low carbon, or even zero carbon, or zero waste. And all this information is publicly available with the 3 cloud providers and on their websites and on their APIs. So what can you do to achieve more sustainability or to reduce your data platform's carbon footprint? You can choose to deploy in the cloud regions that are carbon neutral or are powered largely by green energy, renewable energy. If that is not possible with your primary cloud provider, we also offer multi-cloud deployments to help you get to a region that you may prefer, which may be available in another cloud provider. Another thing to keep in mind here is the impact of data transfer over longer distances. So if you have your users in a completely separate geographical location, then it shouldn't be the case that you're spending a lot more resources over the network traffic. So that is something to keep in mind, and we'll explore that a little bit more. Now, it may not always be possible for you to run your operational workload in regions that are sustainable because your application requires real-time response or you have a very low latency requirements for your queries. That might be true for your operational workload, but there are many, many applications which also have an analytical component to it. And in that case, what is possible to do is that you continue to host your operational workload the way you're doing it, but then you move your analytical workload to dedicated analytics nodes, which is, again, possible with MongoDB Atlas. We have dedicated analytics nodes, which will then bear the workloads such as long-running analytical queries or machine learning workloads. And with MongoDB 6, you can also have analytical nodes that are bigger or smaller than your other cluster nodes. So using workload isolation and deploying these analytical nodes in the regions that are more sustainable is another way to achieve sustainability. And ultimately, this is a concept we discussed in terms of infrastructure as a service or database as a service, but just in general, using software as a service and leveraging the sustainability of scale is another way of making sure that you are reducing the carbon footprint of your data platform. Now, we talked about how we're using better energy, greener energy, cleaner energy, but actually, the greenest energy is the energy that we did not use in the first place. So what that means is that we need to reduce the amount of energy we're consuming. We need to reduce the amount of resources we're consuming to build our applications. The first way to do that is to avoid over-provisioned databases. And what an over-provisioned database is basically where you provision more servers or more hardware to an application that might require less. And the reason you might do that would be just to kind of account for scale that might be upcoming in the future, or if you think that there are going to be peaks in your workload and you need to provision for that. But you don't need to worry about all of that with MongoDB Atlas. In fact, what we've seen is that over 40% of the instances are at least one size larger than they need to be. Now, not only is that a lot more resource consumption, that's also driving up the cost of your overall architecture, So with Atlas, you can leverage cluster autoscaling as well as storage autoscaling to increase or decrease the amount of resources you have provisioned to your database cluster. And this is done in an automatic manner depending on your workload at the moment. If you have predictable workloads, you can also schedule the scale up and down using Atlas triggers, and that could be an even more efficient way to do it. Taking this one step further are Atlas serverless instances. So what we've seen is that over 60% of the organizations around the world are yet to adopt serverless technologies. And the reasons for that are lack of awareness or older risks of security that used to exist in multi-tenant systems and not taking into account the developments that have been made in that space. But actually, with Atlas serverless instances, they are optimized to utilize the underlying infrastructure, such as RAM, CPU, disks, or network bandwidth to its maximum level. And the true power of serverless instances in context of achieving more sustainable architectures can only be harnessed when it is adopted at scale. And the reason for that is that to effectively run serverless instances in the background, we still need to provision servers. We still need to have a lot of estate behind it. And the only time it starts becoming more sustainable is when more and more people adopt it. So it's time to rework those policies, those ideas that you have about serverless, go back and reconsider if it's really not secure for your workloads, and start adopting serverless instances. Another way you can consume lesser resources is by pausing your database when you don't need it. In fact, what we know is that over 44% of the total compute resources are being used in non-production environments, such as development environment, testing environment, SIT, UAT, pre-production, many different kinds that you may all be aware of. So if you think about how much time we actually use these environments, it might be only 50%. Or if you only work the 40-hour work week, then it's 76% of the time you're not using these resources that you've provisioned. So MongoDB Atlas provides a very unique capability to pause a database cluster on demand and resume it when you require. This can be done automatically as well using Atlas triggers again. So this does not take away the data that you had. Your data will still be in the same state. Your cluster will still be in the same state, but you can pause it in the hours that you don't use it and then restart it when you need it, hence consuming even lesser resources. Now, one thing is to use greener energy. One thing is to reduce the amount of energy and resources you use. But even with the energy that we are using, you have to think about how you're using it and optimize that to the fullest. So with MongoDB, we believe in optimizing for data access. So our fundamental data modeling methodology is that data that is accessed together should be stored together. And this is what helps us really achieve these low latency queries, these queries that don't require additional overhead of running joins, for example. And this is made possible with the MongoDB's flexible document data model. I'm not going to go into detail of what that is, but essentially it lets you model your data based on your most frequently run queries or your workload instead of imposing a specific data structure on you. And hence, you can avoid resource-intensive operations such as joins, which you might be familiar with if you're using some of the relational technologies. You can take it one level further by leveraging data modeling patterns. One such example could be the compute pattern, where if you have any computations that you do over and over again on your data, such as adding the total number of reviews that you have for a particular product, you can just use the compute pattern to store that information, the computed information in your documents, and then not have to run that computation over and over again. And this is just one very basic example of how data modeling patterns can help you achieve more optimized and sustainable data access. Now, of course, optimizing your queries is another one. So leveraging indexing way, not indexing everything, maybe leveraging partial indexes and sparse indexes to consume less space, or being mindful about your write concerns and read preferences, or the timeouts of your queries. All these things can contribute greatly to not only making your queries more optimized, but also have them consume much lesser resources. And the final one we have for today from a data platform perspective is knowing the right metrics to monitor. Now, of course, before you can monitor any metrics, you also need to know which ones to monitor, but before that, you also need to have access to these metrics. Now, the MongoDB data platform uses over 100 key performance indicators and metrics that can help you understand your storage consumption, your utilization, your data transfer, so on and so forth. But you also need to think of these in conjunction with each other, such as balancing the data transfer costs versus the regions that you deploy your database in. And you should start thinking about sustainability as a non-functional metrics, same as the way you treat availability SLAs or response times. And instead of doing a trade-off for availability and making your application less sustainable, you should put sustainability on the top of these non-functional SLAs. So is it really important for your application to have that millisecond access time? Or is it really important for you to return all 100 results? Or can your application do with just returning the top 20 results? And so on and so forth. Exposing these metrics to the wider organization so that business decision makers and people who may not be using the data platform on a day-to-day basis also have access to them so that you can make better policies for your organization is very important. Now, in the beginning, we talked about how the data platform is not the only part of your overall architecture. So there are some further ideas, such as using demand shaping. This is similar to what you would see in YouTube videos, for example. So when the bandwidth is low, the video streams in lower quality. So if you know that at a particular time, the energy that you're getting is powered by renewable energy, then you should probably use that time to run more of your workloads and maybe batch processes, for example. And this is information that is also publicly made available by various governments of the cities. It's important to be not only carbon aware, but also carbon efficient, so offsetting your carbon emissions. You can introduce an eco mode in your applications. So users who choose to run their applications in eco mode can then agree to the fact that they will probably have slower response times, for example, but they will know that they're having a positive impact on the environment. Avoiding peaks for predictable workloads, using data tiering. So if you have hot data and cold data, that is like frequently accessed data and infrequently accessed data, you can use MongoDB Atlas's online archive and automatically archive the data to an S3 storage, where the storage is optimized to store large amounts of data on the same amount of, or on lesser amount of hardware. And ultimately optimize your application to minimize the impact on customer devices and processing equipment, and knowing how to make sure that your application is taking into consideration all these factors as well. Now, here's a quote by Werner Vogels, Dr. Werner Vogels, who's the CTO at Amazon.com, and he says that as developers, we're trained to think about how to optimize our architectures for factors like security, performance, reliability, and cost. And in 2022, you can add sustainability to that list. But hopefully, what you saw throughout the presentation today was that you don't have to pick between sustainability and performance or sustainability and cost. In our world, in the world of technology, making the more sustainable choice is actually making the more cost-effective choice, or actually leads to performance optimizations as well. So it shouldn't be difficult. The only difference here is that we need to put it first, and we need to start thinking about it first. In fact, a study by Accenture shows that tomorrow's strongest performing businesses are likely to be twin transformers, which are companies that find new value at the intersection of digital technologies and sustainability. In fact, the study also says that these businesses are 2.5 times more likely to outperform their peers. Now, there are many initiatives around the world in this space. So things like climateaction.tech or the Green Web Foundations are communities with initiatives. There's principles.green that have the 8 sustainable engineering principles. You can also use tools such as the website carbon calculator to understand the impact of your website and how it compares to other websites. And all the 3 cloud providers have tools to calculate the carbon impact as well. So there's lots of resources and communities out there that you can join and start a dialogue or be a part of an ongoing initiative. Now, this is a screenshot I took about a week ago. And this is a live carbon clock that tells us how much time we have before we reach the tipping point. So at the moment, we have less than 8 years. And while we talked still about factors such as performance optimization and cost optimization and business growth and development, sustainability is enough by itself to justify our work. And you and me and all of us, we need to start putting it first. Thank you for your time today.